So it's 510 is the last section, and I think this kind of stuff is really fun. This is the part of geometry that I really got a kick out of, that I enjoyed doing the problems. So 510 is called problem solving. So problem solving, areas of irregular figures. So areas of irregular figures. So we've done, how do we get the area of a triangle? How do we get the area of a square or rectangle? How do you get the area of a trapezoid or a parallelogram? Now what we're going to do is we're going to throw like weird shapes at you and say find the area. And basically what you do is you take this weird shape that there's no equation to get the area for this weird shape, and you hack it up into rectangles and squares and triangles. Or you could do parallelograms and stuff if you wanted to, or trapezoids. And you hack it up some way and then find the area. So I always thought it was kind of fun. Either a pro or con, there's different ways you can cut them up. So how I cut up mine on my answer key might be different than how you do it on your quiz, and we both get the same answer. So you kind of have options for like playing to your strengths, like which ones are easier for you, then you try to use more of those shapes. I'm going to try to throw some steps down there because that's kind of how I think. I like that kind of linear. And you could skip writing it, you could write it, but I think it might come in handy. So my step one is I'm going to say divide the figure up into parts you can find the area of. So divide, maybe I'll say the shape up. Divide the figure, the shape, up into parts you can find the area of. So into triangles or rectangles, squares, trapezoids. So into parts you can find the area of. And then once you have it broken up, I'm going to say, like, if necessary, find the missing sides. So if necessary, find the missing sides. Because sometimes when you break something up, you're not going to have the side of a square that you made. But you usually could figure it out from the sides that you know. So find the missing sides. And then last but not least, find the areas and add them together. So find the areas and add them together. And I'm going to do two examples in here. And like I said, there's two ways to break them up. I'm actually looking at my first example right now and thinking, well, why would I break it up that way? This way is easier. So we'll kind of see which way you guys pick, if you like the way I did it or if you want to kind of do it the other way that I just saw right now. Everybody have it copied? And I can always come back to that at the end if need be. So example one, I'm just going to say find the area. So find the area. And try to draw a shape that looks kind of like this, you know. Maybe things just won't completely be to scale. Let me throw some sides on there. So I'm going to say this long side on the left is 20. The very bottom is 12. Kind of that vertical part on the other side I'm going to make into a 10. And then we'll put a 30 across the top. All right, how do you want to break it up? Go for it, Abby.
Well, right under the weird angle, you cut it off.
Okay, so you're saying put in a horizontal right there?
Yeah.
Cool. So we have two parts we need to get the area of now, right? The top is a... Okay, I guess we could break it up even more if you wanted to. So, I suppose we could do this. The top is a trapezoid, right? So if we wanted to, you could, for the top, do 1/2 times the height. I don't know if I'd write this yet. We'll see what the group wants to do. But we could go with this equation there for that top section. Agreed? Or someone was saying we could break it up here as well. Do you have a preference? You like the second way better? Okay, so we'll do it this way the first time at least. So this is the equation for the trapezoid. And now the bottom one, is the bottom one a rectangle or a square? Looks like a square, my drawing's bad. But it's actually a rectangle because I have one side that's 12 and one side that's 10. But we could say the area for that is going to be the base times the height. And now if we take and plug in our numbers, okay, for this top part we need to define some numbers. So
we're not doing the line.
well, this top one we're trying to do this here. What's kind of this shaded area right there? So we have area equals 1/2 times the height. Ooh, what's the height? The height has to be 10. Do people see how you can get that this side here is 10? The whole height is going to be 20, agreed? And right here we have another 10. So if that's 10, do you agree this side here has to be 10? So my drawing's a little bit off. But if this side's 10, then our top has to be 10 to add together to give you 20. Right? So we have 1/2 times 10 times base 1 plus base 2. Well, the top base is going to be 30, so I'll put that in as base 1. But now what's going to be the length of that bottom side of this here in red? This here has to be 12. And maybe I should have gone through and labeled this before I had you break it up into like be right angles and stuff. I kind of made that assumption. But then we could put in our 12 right there. And now if we punch that into a calculator, so we have 1/2 of 10, so that's going to be 5. So I have 5 times 30 plus 12 is 42. So 5 times 40 is 200, plus the 2 is 210. Did you guys get the same answer? I saw one person punch it in. So that top part's 210. Questions on the top part? Right. So then the second half, we have this on the bottom. I'll maybe kind of scribble it in brown a little bit. So that's what we're going to use this equation for. And the base is going to be 12 with a height of 10. So that's 120. So the green on top is 210. The brown on the bottom is 120. If we want to get the total area, we just add those two spaces, those two areas together. So we have 210 plus 120 gives me 330. So if we did it all right, we should have 330 square units, whatever that would be, but 330 for our area. The second way, I don't know if we'll actually go through and do the whole problem, but what I realized when I was looking at it just a moment before we started was if we broke it up this way, try to make that look a little more vertical, so I have a little right angle there. Now as we go through and put in, well, this was 20, this was 30, this was 12, and 10, we could do the area of this big rectangle, right? How do we get that? What times what? Base times height is perfect. 12 times 20, which gives us 240. I don't think I'd try to rewrite all this. But now we just need to add to that the area of this triangle. So that's 1/2 times base times height, right? So you have 1/2 times, these might get a little bit trickier. If I took and turned this 90 degrees, though, that would make this side here be my base. What does the length of that red thing have to be? 10. So that was 10. And then my height would be here in blue, this side here, and that height has to be, not quite, the whole top is 30. We need to take off our 12 down there on the bottom. So it should be 18, right?
Yeah.
Okay. So we'd have 1/2 of 10 times the 18. 1/2 of 10 times 18 is 90. Then once we have that, 90 plus 240 gives us 330, the same answer as before. So 330. When you do the 90 plus the 240. Okay on that one? Then we did I guess really we did 2 examples. So this next one, I don't know if you want to work all the way through it. Next one is a little bit more of a challenge. You could, if you want to, just watch. But so I'm going to say 8 and 5 and 6 and then down here. So something like that. And I'm going to say that the whole height is 12. So I'm going to say this, if you would do like a straight thing there, that's going to be a height of 12. And you could choose to cut it off there. You could choose to cut it off someplace else if you wanted to. Up at the top we have an 8, this is 5, and this is 6. So in reality my base should be a little bit lower, that this probably should be down here a little bit more, but I'll leave it the way it is for now. Nope. Alright. Alright, how do you want to break it up? Anyone? Thoughts on that? So go for it, Kayla.
That little bottom,
Okay. Okay, so we're saying we're going to make this into a little rectangle, so we have one shape right there. Okay, good. And then do we want to leave the rest of that as a big trapezoid, or do you want to change that into a rectangle and a triangle? Leave it? Okay. So we'll leave it, but if you don't like trapezoids, they're not my favorite shape, you could put a line there and then have your triangle be one area, and then get this as your second area. But we'll leave it. And then we just need to find some missing sides. If we're going to get this blue rectangle, we need to know the height. So what number do we have to put right there? Go for it. Not quite 6. Close though. Nice try. So, not 8. It's between 6 and 8. You see? Go for it. 7. Nice. Do you mind telling us how you got the 7? Or, oh, I guess that would work. Oh yeah, the numbers are right next to each other, aren't they? Bummer. Well, we know the whole height. I didn't mean to give it away that way, but we know the whole height is 12, right? So if that whole height is 12, this part right here is 5. So we kind of know that like this much of it right there is 5. 12 minus 5 would give you the rest. 12 minus 5 would give you that part of the segment. So, but that was kind of the stuff I enjoyed trying to figure out. It's like, okay, I want to do this. How can I figure out that this side here has to be 7? But then we could say the area of the rectangle is base times height. So we'd have 6 times 7 for a 42. So this part right here is 42. And then this large trapezoid is going to be 1/2 times the height times base 1 plus base 2 in parentheses. So half height times the sum of the base 1 and base 2. And so we have half of 12. Base 1, one of our bases is 8. Now we just need to figure out the other base. So the chance to figure it out without me telling you, and in this case, it's the number that I forgot to write in, because otherwise we wouldn't be able to figure it out. So my base was supposed to be 20, so I apologize, I missed that. So put a little red 20 there. So now we have 1/2 of 12 is 6. 6 times 28. Thank you for your help. So 168. And so if this bigger area is 168, we could do 42 plus 168. And so 210. So you had 2? Okay, nice. So 210. Really?
That's what my dad liked.
So here's the equations you can use to find the areas of those different shapes. You might want to pause the video and write it down if you don't have them written down already.